But you're always checking to make sure that you have descending exponents. So on example 2, and that's for your, it's really for both, but most importantly for your dividend, my dividend has the highest degree of 2. So I have to make sure I have a squared, a first degree, and then a constant. And it does, so I just put it straight in. Okay, so now, you completely disregard everything but the first term of each piece. This is just regular old division. Then I ask myself, what would I multiply x by in order to get x squared?
So,
just x, right? Because x times x is going to give me x squared. And that's what you're trying to figure out. So once you have figured that out, then you do exactly what I just did, and you multiply. X times x is x squared. X times negative 3 will be negative 3x. Now you're going to change the signs on everything underneath and add straight down. Now we do that instead of subtracting. In 5th grade you subtracted. But because these are polynomials, and sometimes they have opposite signs, you're going to just change the signs on everything underneath and add straight down. And then the process starts all over again. So you ignore everything but just one term of each, the dividend and the divisor. What would I multiply x by in order to get 8x? 8. And it would be positive 8, so I'm going to put plus 8, and then multiply. 8 times x is 8x. 8 times negative 3 is negative 24. Now, you are going to change the signs on everything that you just wrote down. So it'll become negative 8x and positive 24. And you add straight down. My 8x's cancel, and this leaves me negative 4. Now, when I get to here, I can try to continue and figure out what would I multiply x by in order to get negative 4, but there is nothing. That makes this minus 4 a remainder. Now, we talked about yesterday, when you very first started learning division, the first step was r. And you put an r and then just move your remainder up there, and that was it. And then the second step was the one that you're going to use for polynomials. You take that remainder and you put it on top of a fraction. And the denominator is going to be your divisor. And that's how we do it for polynomials, to find the remainders. Okay, so on example 3, it's asking me if x equals 3 is a solution of this. So x equals 3, I'm going to find out by dividing, but x equals 3 is not a polynomial. And if I'm going to do division, I need a polynomial divided by a polynomial. But if I take this x equals 3, and I move this 3 to the other side, what will it be when I do that? X minus 3. And x minus 3 is a polynomial. It's a binomial. So that can be my divisor. Now, when I plug my dividend into the house, I have to have descending exponents. Right now, my degree is 4. So I need a 4, an exponent of 3, an exponent of 2, 1. You don't have to have a constant, but if you do have a constant, that's fine. So I have a 4 and I have a 3, but I don't have a 2. So I'm going to go ahead and put my 4 in, x to the 4th minus 2x to the 3rd. And when you get to the squared value, you're just going to plug in a 0x squared. It doesn't matter if it's positive or negative because zeros can't be positive or negative. So it doesn't matter if you put plus or minus. I'll just put plus. Plus 0x squared plus 3x plus 1. Now putting that in there does nothing to the polynomial because 0 times x is just 0. It's like it's not even there. It is just a placeholder to keep your numbers lined up. You technically don't even have to put it there, but it's a whole lot easier if you'll just put it there, keep your numbers lined up, and not have to worry about it. All right, so now we disregard everything but the first term of my divisor and the first term of my dividend. What would you multiply x by in order to get x to the 4th?
So
X cubed, right? So x to the 3rd once you figure that out, you go ahead and multiply. X to the third times x would be x to the fourth. X to the third times negative 3 would be negative 3x to the third. Now, you change the signs on everything underneath. So the x to the fourth becomes negative, and the 3x to the third becomes positive. Adds straight down. And then the process starts all over again. I ask myself, what would I multiply x by in order to get x to the third?
X squared.
X squared. And since it's just plain old x squared, that's positive x squared. So that's what I'm going to put on top. Once you've put it up there, the next thing you do is just multiply by all the pieces in the divisor. X squared times x is x to the third. X squared times negative 3 is negative 3x squared. Change the signs on everything underneath and add straight down. And then you start all over again. I ask myself, what would I multiply x by in order to get 3x squared? Positive 3x. Now you multiply. 3x times x is 3x squared. 3x times negative 3 is negative 9x. Change the signs on everything underneath. Add straight down. You get 12x plus 1. What would I multiply x by to get 12x? 12. Okay, so now this time I get to here and I ask myself, is there anything I can multiply x by to get 37? No. Which means 37 is a remainder. So now if they were asking me to find the solution, I would put it up here as plus 37 over x minus 3. That's how you write a remainder in polynomial division. They didn't really ask that though. The question was actually, is x equals 3 a solution? Is it?
No.
Why not? It's not, but why isn't it? How do you know it's not? It didn't evenly divide. If it was a solution, I would have gotten a remainder of 0, just like we did when we did this first one over here. Because it was a factor, it divided out to be 0. This one doesn't. So the answer is no, it is not a solution. Alright, try number 4. I'm going to give you a minute to try it on your own. So the first thing I have to do is I have to take my x equals 1 and move my 1 over, make it x minus 4. So that's going to be my divisor. My dividend starts out, it's a cubic, so I should have 3, 2, 1 constant, and I have a 3 and a 1, I'm missing 2, so I am going to have to put a placeholder. Okay, so x goes into 21x cubed, 21x squared times. Now x goes into 21x squared, 21x times. Okay, so in this case, is x equals 1 a solution? Yes, it is, because I got a remainder of 0. Okay. So, okay, so each of these, they're actually exactly what we just did, pretty straightforward. Just check, make sure that you're looking for a placeholder, and, because you'll need a placeholder. And on the back, this is one thing I don't know that I mentioned, because I think I did mention it, but just in case I didn't. On the back, if you look, not only do you need a placeholder if you're missing, so like number 7 is, the highest degree is 3, so I'd need 3, 2, 1, and a constant, which I have. But, they're in the wrong order. So they also need to be in the correct order when you put them inside of the house, so make sure your dividend is ordered correctly also. And before you actually do this, I want you to look at problem number 1 and problem number 2 also. It's probably more obvious on, well actually problem number 2 is not good. Problem number 1, I have 4x squared minus 9. That's a difference of two perfect squares, and it factors, and you could factor it. So, and you'll get your same answer that you're going to get when you divide. The difference between factoring and dividing is that dividing actually gives you one of the factors to begin with. When we were factoring, like for example, I had x squared minus x minus 6. And you would factor that. What is that?
X minus
X minus
2 or
3 and x plus 2, right? So I factored that from nothing. They didn't give me either of the answers. I came up with both of them. Division, they would do this. X squared minus x minus 6 divided by x minus 3. And you would come up with the other one. So factoring is division. It's just coming up with both of the factors at one time. Whereas division, you're given one to start with. Now, the reason we need it, we're starting out simple. But we've got to have division because we only know how to factor quadratics and only very special cubics, which we'll kind of review a little bit tomorrow.
The 4x squared would be in the house.